All right. Hey guys, nice to meet all of you. You can probably see my name there. It's a little hard to pronounce, so bear with me. Most people just call me K, the first alphabet of my name. So if it's easier, we can do that today. So a little bit about me. I'm an ML engineer at Shopify, lead a couple of teams there. I have over 12, 13 years of experience in the ML space right now. Try to remain as domain agnostic as possible. So I've worked in retail and healthcare and ad tech, and yeah, I've moved across a little bit. So you see the third point there, right? It says strong believer in systems thinking. What do I mean by that? Well, for the most part, like I think there's a dichotomy that's sometimes created where they're kind of like you can either move quickly and break things, or you can think a lot and you can build these well thought out, structured systems that are long lasting, right? I think my personal opinion's always been that's a false dichotomy. Like you can do both, right? You can build quick, you can break things, move fast, the hacker culture, if you will, and also at the same time move towards that longer term sustainable systems thinking. And so that's kind of been my thing throughout my entire career, and that's led me to where I am right now. And so and you're going to see a lot of that in the talk that I'm going to give with Niklas in the next few minutes. And then dogs, music, video games in that order. Never, ever change the order in that order. That's how I spend my time outside of work. And you'll actually see my dogs during this talk as well. I always promise people dogs during my talks. So with that said, Niklas, why don't you tell us a little bit about it?
Okay, a little intro about me. I'm a senior ML engineer at Shopify, originally from Finland. I started my tech career at Shopify as an intern, as a data science intern in 2018. Been working on various ML products and ML solutions like fraud detection, product classification, and so on. Into mathematics, chess, playing music with other people and my coworkers. And I recently got a dog, and you can see the picture, kind of an abstract picture of my dog as well here. Gonna pass back to Kay.
Thank you. So here's what we're going to do today, right? So again, I'm not going to read out the entire agenda, but at a very high level, introduce you to the problem statement, and then kind of talk about like the high level, why multimodal LLMs, how does this fit this problem space? Then we'll get into the nitty gritty of like, actually, how did we train this? How did we fine tune? How did we create the data set that was required? Evaluation, and that's where Ray comes in. And then we'll kind of get to the fun part, in my mind at least, is like, how do we serve this in production? Because everybody plays with LLMs, right? Like we've all tested LLMs, but to do that at scale, turns out it's much harder than what most people think, right? And the scale we are doing it, I'll give you a rough teaser to this. We are doing about 50 to 70 million LLM predictions every day right now at Shopify, right? Just for this product alone. And so how do we do it at that scale that's cost effective and latency sensitive and all of those things, right? And so we'll get to that. And then finally, we're going to end with my favorite topic ever, which is, okay, we did all of this work. How did it help anybody? Did it make anyone's life better? Like how are we actually helping our customers, right? And so that's kind of what we're going to do today. So let's jump into it, right? So how do we make sense of like why do we need this product, right? Well, turns out Shopify is really good to our merchants. And what I mean by that is we allow our merchants to customize their store any way they want, right? So if you look at the screen in front of you right now, that is typically, so if you were a Shopify merchant and you were creating a product at Shopify today, that's kind of the rough interface you get, right? So you can put in any title you want, any description, you can add media, you can add images, videos, 3D graphics, whatever, right? Complete flexibility, complete control, right? Turns out this is great for our merchants because each individual storefront that's created on Shopify is completely different from the very next. Turns out it's also terrible for Shopify because we have no way to standardize anything, right? So if there are 10 different stores on Shopify all selling the same Samsung Galaxy phone, turns out we don't know that it's the same Samsung Galaxy phone because the title could be different, the price could be different, the description, so many things about it could be different, and we have no way to know. The merchants could tell us, they could give us like a GTIN number or something, but that's usually not done, very, very sparse. And so we have a problem where we don't know what our merchants are selling. And that makes it hard, right? It makes it hard for multiple reasons. Primarily among them, A, like I said, we don't know what our merchants are selling, right? And that makes it difficult for a couple of reasons that might not be very obvious. For example, taxes. Here in the United States, how much you tax for something not just depends on what the product is, it depends on where it's being sold, where it's being bought from. It's just complicated, right? Taxes is like a primary use case of this. And then there's just the usual search and discovery and recommendation systems and all sorts of things, right? And so legal compliance, right? There's so many things where it's important to know, not just for us, but for the merchant as well, what is the product that's being sold, right? Second, again, I already spoke about search and filtering. We ourselves want to know analytics, right? Like end of every year, we want to know, hey, how is the market doing for clothing? How is the market doing for, I don't know, automobile parts, right? And so on and so forth. It's important to have a standardized view of the world, right? And so in order to do this at scale, we need essentially two things, right? One, we need a well-defined, well-understood, well-agreed upon definition of what the world looks like, right? Which means I need a control list of categories. I need a control list of other metadata around those categories, right? So that's number one. Number two is then I need some sort of ML system that is able to take billions of products, tens of billions of images, and categorize them into that space, right? So that is the problem statement that we're looking to solve. And so this is where Niklas comes in, and he's going to talk about all the great work he's been doing.
Thank you. All right. So the first step to solve this problem was to create and define the Shopify product taxonomy. So basically, the Shopify product taxonomy consists of two parts. We have product categories, which is what you might imagine. It is what kind of a product it is. Is it a shoe? Is it a T-shirt? So on and so forth. So you can see the categories have these different levels, these different varying levels of granularity, starting from the coarsest category to going all the way up to a finer category that could be more like specific to the product. So in this example, you can see that on level 3, we have athletic shoes. But on level 2, we have shoes, and on level 1, we have apparel and accessories as the category. So it's always this hierarchical classification for products. So we have this taxonomy tree. So this is very useful from multiple points of view. First of all, if we're unable to classify a product in the finer grain, at least we'll have some kind of coarse classification of the product, hopefully. But it also allows us to ask questions about how many shoes did we sell in the last week. But it also allows the user to search for athletic shoes in our shop app, which is like selling products online. So we can have like very specific search results, but at the same time, we can have this higher level views into what products are selling, for recommender systems, so on and so forth. On the right-hand side, you can see that we also have this metadata that Kay mentioned, which we call attributes. So these attributes are a function of the product category. So you can imagine that for different kinds of products, we need different kinds of metadata. So for example, here you can see for athletic shoes, we have things like shoe fit, toe size, etc. But we have also more generic attributes like color, material, and so on and so forth. So for each category, we actually have a unique set of attributes that are attached to it. So in order to know what attributes to have for a given product, we first need to know the product category. So you can imagine that some of the attributes that we have, like material, can vary from product to product. Like T-shirts could be like cotton or polyester, whereas chairs could be made out of wood or metal or something like that. So it's not the same values even within the attribute key for each product. So this is kind of our starting point. We have defined with our product team this very structured taxonomy of categories and attributes. Then, in order to actually map all the billions and billions of products at Shopify into this structured taxonomy, we have chosen to do a two-step approach using multimodal vision LLMs. So here you can see kind of a bird's eye view of our flow. So as Kay mentioned, we have these unstructured text fields that can contain all kinds of different things depending on the merchant. They might list their variants, color options. They might put like a lot of different details about their product, like what kind of things it can do. And then we also have product images for those products, and this is where the multimodality comes in. So we have fine-tuned these LLMs to be able to predict both the product categories and the attributes. So here you can see an example. We have a Shopify classic hoodie. The dictionary definition of cozy should be this hoodie. And first, we supply all the text fields and the image to our fine-tuned category model, and then we get a category prediction, like apparel and accessories, clothing, outerwear. Great. Now that we know it's an outerwear product, we can go and retrieve all the relevant attributes for that product. So here you can see things like age group, care instructions, color, fabric, outerwear material, so on and so forth. Then when we have that, we actually supply the same unstructured text fields, the product image, the predicted category, as well as the allowed attributes and their values to another multimodal fine-tuned LLM call, which produces the product attributes. So here you can see things like color would be predicted as black, age group adults, material polyester, so on and so forth. So diving a bit deeper into the category predictions. So this is kind of a very high-level view of the flow there. We have these text fields, title, description, tags, whatever text fields we have access to. Product image, in this case, it's an AI-generated image of a smartwatch. And these are passed to the category model. And we have fine-tuned the model to output structured JSON, where you can see the first row is product category. But we actually ask the model to do a bit more than that, because we don't have these standardized descriptions. They're also useful for various use cases, for like searching products and so on and so forth. We generate AI-generated, these LLM will also generate product descriptions that are standardized across all products. And we also ask it to generate an image description, so which we can use downstream for other use cases. And this actually helps the model reason about the categories better as well. And here you can see we have a prediction: apparel and accessories, jewelry, smartwatches. But even though we have fine-tuned the model with product categories that belong to the actual taxonomy, in reality, it's never really that easy. So the model can still hallucinate product categories that are actually not part of the taxonomy at all, which makes us unable to retrieve the attribute values. So how do we deal with these kind of cases? It doesn't happen very often, but it does happen. So here you can see a prediction: apparel and accessories, watches, smartwatches. So while it looks like a very solid prediction, it's not actually part of the taxonomy at all. So how we solve this is, after we make this raw prediction with the LLM, we have this step where we have created a FICE index of all the actual allowed category values. And we use the raw prediction to search the closest matching real taxonomy value. So here we would actually get apparel and accessories, jewelry, smartwatches from the FICE index. It works phenomenally well, and now we have the appropriate category for the product. So then the next step is to retrieve the attributes for that product. And in the category use case, you might ask, like, why wouldn't we just supply all the allowed categories for the model to begin with? The reality is there's over 12,000 different categories. And because they have this hierarchical nature, they're extremely long. They take a lot of context window space. So we are not able to do that with the current model architecture that we have. But with the attributes, we're actually able to do that now that we know the category and we know its specific attributes. But here you can see kind of like how when you look at the different values and allowed values of the attributes, you can see that there's still a lot of stuff that the model has to pick and choose from. So it's really, really rich, this taxonomy. Very similarly to the category model, we also supply the text fields, we supply the image, we supply the category of the product, and we supply the attributes. As like, here is attribute color, here's the allowed values for color, here's material for this product, these are the allowed values, so on and so forth. And the model is fine-tuned to, again, output structured JSON. So here you can see that the JSON keys are the attribute names, and the attribute values are in a list because there can be multiple attribute values per product. So here you can see, for example, smartwatch features has GPS support, heart rate monitor, so on and so forth. If you have a multicolored product, it could have like the colors listed in order of dominance. So you can get like a very rich set of attributes per product. So in order to actually fine-tune these models and to evaluate them and iterate and figure out how the models are performing, we needed a source of truth data set. So we needed to create this, what we call a golden data set. Luckily, we had some merchant-labeled categories already. So we already, in our product page, had the ability for merchants to choose from a previous taxonomy that was kind of based off of Google product taxonomy. So we mapped those products from that taxonomy to our new taxonomy and looked at the merchant-labeled categories. But unfortunately, we discovered that merchants are not expert in product taxonomy, so they tend to mislabel their products quite often. So how did we fix this? Again, using LLMs. So we would again supply the unstructured text fields, image, and a question. Is this merchant-labeled category prediction, or this merchant-labeled category, is this correct? Or would you suggest that we would have something else? And the model would often suggest, like, oh, I don't think this is actually correct. You should maybe use this one instead. And then we would have a human in the loop to verify that these corrections would be good. And then they would be added to the golden set of categories. And now that we have the categories, we can make category-specific prompts where we actually populate all the allowed attributes and their values, and again ask an LLM, what are the attributes of this product? After human in the loop, we have golden set attributes, and together they form the taxonomy golden set. So our artifact repository in general is Hugging Face. So this is where we keep our golden set. We do have we're adding more categories to it. We're adding more annotations, so on and so forth. This is an ever evolving data set. But here you can see that we have the categories and we have the taxonomy attributes. So how does this fit into fine tuning? At a high level, we formulate questions for the model from unstructured text fields using the product image. And in the attribute model case, we're supplying the category and the attributes. And from this golden set, we get the answers. And these question-answer pairs are then used for fine-tuning the model. So to go a bit deeper into detail, I'm going to give the mic back to Kay, and he's going to dive into the actual fine-tuning process.
Thanks, Niklas. All right. So how do we fine-tune the model? Well, so we use something called SkyPilot, which is actually built on top of Ray. SkyPilot is pretty cool for one reason and one reason alone. In the world of not easily available GPUs, SkyPilot gives us the ability to declaratively just I write there's a YAML like that. And you see that on the very top, there's this field that says resources, and I've mentioned Cloud GCP. If I remove that one line of code, and then I basically tell SkyPilot, launch this, it'll basically search every cloud that's available to me, whether it's GCP, whether it's AWS, whether it's Azure, maybe your own Kubernetes cluster somewhere, right? It can run and find resources for you pretty much from anywhere you have access to. And so what that means is I don't have to worry about, especially for fine tuning, right? Because you're running this as a one-time thing and it's running somewhere. You don't really care where it necessarily runs. You just care that it runs quickly. You have the resources. And so we use SkyPilot for that. And then again, like Niklas said, Hugging Face is our repository. So we have scripts that pull, SkyPilot creates a cluster, creates how many of our GPUs I need, pull the data set from Hugging Face, run our fine-tuning on top of that. Fine-tuning is basic. Most of you have already done it at this point. And then we use weights and biases to track our experiments, right? So at any given point, we can kick off 5, 10, 15, 20 of these. The only limitation is we have enough GPUs across all these regions that we're searching from. But as long as we have that, SkyPilot can run and it'll create our experiments run and we get what we need, right? And then we have to evaluate the model. It's not just enough creating, fine-tuning a model. We need to evaluate and see how good it is. This is where Ray has been super helpful to us. Because again, and I'm going to talk about how we deploy in production, but remember, evaluation is pre-production, right? This is not going to run in production or anything. So I needed a way for us to test predictions and then calculate some sort of metrics on top of it in a reasonably large scale, right? So we're talking about 1 million, 2 million predictions from the LLM, right? And so the way we would do it is we would, again, go back to SkyPilot to create a cluster. And like I said, SkyPilot is built on top of Ray, which means you still have access to the Ray fundamentals. We would then use Ray actor pools to create, and we would use SGLang, which is one of the inference frameworks available. Again, that's an implementation detail. VLLM, Triton, there's a bunch of these things, right? So you could use all of those, but essentially then use Ray actor pools to parallelize and distribute the workload across multiple nodes. And then it would batch predict on a bunch of known products and known inputs. We get the outputs and then we calculate a bunch of metrics on top of that, right? So we do that and then we saw this, right? What does this mean? How much did using vision LLMs improve our system? For categories where we actually had a previous multi-layer perceptron model, it improved by that much. Again, I can't lie, I'm squinting at those numbers. Maybe you guys can't see the actual numbers, but again, remember the taxonomy is hierarchical, level 1 all the way down to level 7. At every level of the taxonomy, we saw an improvement of both precision and recall. Remember, the taxonomy is about 12,000 or so categories, 40,000 or so attribute values. And so it is a difficult space to choose from. And so we're seeing those kind of jumps in precision and recall. Obviously, this comes at a cost. Nothing's free in life, right? So this is coming at the price of, it used to be this tiny BERT-based multi-layer perceptron model running before. And now we've thrown a 7 billion vision LLM at it, right? So it's a much more expensive model to run, but it comes with the benefit of that kind of improvement. So when we saw those numbers, we were like, yeah, we need to see how we can deploy this to production. Yes, it's going to be hard, but we need to do it. So how do we do it? Turns out even there was a complication, right? Because it's not just one way we needed to serve this model. We needed to serve it in two different ways, right? On one hand, there is a subset of our users who are logging in. They open up their computer, they log into Shopify.com, and there's an admin, right? So they're physically clicking buttons and creating products. This is very low volume. Most of our products aren't created that way, but it is an important way that merchants are creating. And so for those users, we wanted this model deployed so that it's in real time returning predictions. So if I type iPhone 15, the model should in real time return back to the merchant saying, we think this is a phone and we think the brand is Apple, and so on and so forth, right? So you have the real time, low latency, albeit low volume. Again, when I say low volume, I'm talking 1 or 2 million predictions a day in that mode. But like I said, most of our predictions don't come in that mode, right? Most merchants are using APIs and bulk editor and these large volume, high throughput. There, I care less about latency. I care more about throughput, right? Like 20 million products are created today. Well, I need all 20 million of them categorized and tagged with this model, right? So you have these two different modes of operation. So how do you serve in production? Again, on the right-hand side, you see a flow typically right now of how merchants are creating products. So you will see I'm going to try to sell the beds my dog was sleeping on. So I list my bed, and immediately in the bottom you saw that purple thing pop up. That's the model predicting, hey, this is a dog bed. And then I scroll down and it's predicted the color and the shape and whatnot. So this is happening real time, right? So as the merchants are typing, they see this. How do we deploy this? Well, we used NVIDIA Triton. And then behind it, we used LM deploy. Again, implementation detail, right? We've tried LM deploy, SGLang, VLLM. There's a bunch of these things, and we keep changing it every few weeks when more improvements come up, right? But essentially, a Python backend for NVIDIA Triton. It's hosted on our Kubernetes platform that we have at Shopify. And yeah, this is serving real-time traffic for our merchants, right? But again, like I said, low volume, low latency, right? Now we come to the larger part, right, which is the high throughput, high volume use case, right? This needed, again, latency is less critical here. Yes, I don't want it to take 24 hours, 48 hours. I need it in seconds, if not minutes. But this is where we're talking high volume, 50 million, 20, 50, 60, 70 million products are getting created, edited every day, right? How do you do that? Well, we use Dataflow as our streaming engine. Kafka as our source and sink, right? So our Shopify core backend systems are writing into a Kafka topic saying, hey guys, these are the products that need new predictions. These are the updates for these predictions, or these are the updates for these products. Dataflow reads it in. Dataflow downloads the required media, images or wherever from our CDN. It then sends it over to the Kubernetes platform where our models are hosted. It's the same hosting, by the way. It's the same backend system. It's the same Kubernetes cluster where we're hosting for real time, except it's optimized differently. Turns out for high throughput, high volume, you overload the memory, right? So you overload the memory because that's where you get the most bang for your buck. And so it's just optimized differently. It goes to the Kubernetes system, gets back a response. Dataflow does all the cleansing, sends it back to another Kafka topic, goes to its sinks. So that's how we do this in the second mode, right? So now let's talk about impact, right? How has this been useful for us? Well, search is already better, right? In the last 2-3 months, we've rolled out a bunch of new experiments in search, which have made search better. We've introduced new filters in our shop app. Our recommendation systems are using it. Trust and Safety just recently told me they were able to identify a bunch of fraud use cases because of this. And all, I'm not going to talk through every single use case. It's just enough to say that this is a foundational part of Shopify's data infrastructure. And so, yeah, and the other great thing for us is merchant adoption. Like you saw in one of those slides, we make these predictions visible to our merchants. The number of merchants who not only say, yes, this is correct, but they'll interact with it, they will accept it, and then they will make it part of something. Maybe they use these categories as definitions for how their store is organized, right? And so we've started seeing merchants adopt and make use of these things. And so, yeah, it's been great for us to see this, right? And with that, I will stop. I know we have about 4.5 more minutes. If anyone has questions, there's a microphone on the front.
Yeah, thanks. Great talk. I wonder, you mentioned you're fine-tuning your model for these categories. Two questions. One is, are you then fine-tuning a generative text model, or are you actually fine-tuning a classification head on top of it?
Can you repeat that question?
Are you fine-tuning basically a text generation model that outputs JSON? Or are you fine-tuning just a classification model on top?
No, it's just a text generation. It's an LLM, right? So it just generates text. It generates it in a JSON output. And so you get essentially a text string. And that's where what Niklas was saying. Sometimes the text string doesn't match exactly with a known category. And that's when we use the FIES index to map it back to a known value.
Okay, thanks. Then the follow-up to this. When we fine-tune models like this, we always run into overfitting, especially if you have very reduced use cases. We run into overfitting into the basically distribution of your training data set. Yeah. Have you taken any steps to avoid that?
Yeah. So first of all, like, it's funny because if you spoke to me 2 years ago and somebody asked me, hey, predict what category a particular product is, I would have just said it's a t-shirt, right? It's a running joke inside Shopify where if you don't know what something is, it's a t-shirt, right? So we have an extreme skewed distribution of the kinds of products that are being sold, right? So we had to take a lot of steps in order to like stratify how you sample and like just the data set creation, we had to be extremely careful so as to not introduce any sort of weird bias in there. So that's step one. Step two is, again, you just monitor your fine tuning, make sure your data set is big enough, hyperparameter tune, you monitor your loss curves. Yeah, so I mean, the answer is no different for LLMs than it would be for any other ML model that you fine tune or you train. The only difference being LLMs are a lot more, it'll step into that realm of overfitting a lot more easily than any other model will, right? So in terms of like the actual how do you prevent it, it's not very different from any other ML model. It's just, it happens a lot more easily in LLMs.
Thanks.
Yeah, so what kind of vision LLM you guys use for fine-tune?
Yeah.
Flipper or maybe instruct flipper, or what kind of, yeah.
So we've used Lava, if you've
Lava.
heard of that one. So Lava was the first one that we tried, but we're moved since to other models. So we've tried Phi 3.5, Llama 3.2, and Intern VL. So we tried a bunch of different ones.
Okay, so you use Llama to generate the title or something category.
So right now, the model that's in production is Lava, right?
Okay.
So Lava is the model that's in production, but we're not stuck to one particular model, right? Because in the space, as most of you know, things are like improving every day. So the way we've built the system is like it's agnostic to the model for the most part, right? And I'll come back to why I said that. So if tomorrow a new vision model comes out and we think it's better, we will try it out immediately and we'll see, hey, this. And the reason I said for the most part is because for inference in production, there are limitations, right? Because what we've noticed is a lot of these frameworks, VLLM, SGLang, LM deploy, they're all hyper optimized for Llama-based models. And so when a new model, let's say Microsoft Phi 3.5 comes out, from a pure accuracy, precision, and recall perspective, does it do better than existing Llama-based models? Most of the times, yeah. But then it turns out deploying it in production is a different story because these frameworks aren't as optimized for those models. And so the cost differential doesn't start make sense, right? And so it's always this balance between how much can I optimize this model for production versus how accurate it is on the other end.
Okay. So one more question. Suppose your taxonomy side, if you add one more categories, what do you guys to do? To do backfill in or what kind of thing?
Yeah, so that's a great question. So it depends, right? It depends on what kind of change it is. Like for example, let's say t-shirts was a terminal category today, and tomorrow we say, hey, let's just add polo t-shirts and round neck t-shirts or whatever. You just add more children to an existing category. Then what we would do is we would go and identify all products that were labeled as t-shirts and only repredict for those, right? So whereas if let's say we split something more fundamental, let's say we introduced a completely new branch of the taxonomy, then you'd probably have to go and do a full backfill, right? So it is basically you'll have to look at the exact change and then determine what portfolio or what area of your portfolio does that change affect, and then you'd have to run it. So it is on a case-by-case basis.
And then there's the nuance that when you change categories for any products, then you have to also repredict all the attributes, because the attributes are a function of the category, right?
Yeah.
So we have this flow going on where first, if the category changes, then like let's say we add more of these leaf nodes, we isolate those categories, we predict human in the loop, and then we predict attributes for those categories only after the fact. So there's this whole fixing loop, and then you have to fine tune the models again, evaluate them again, and then we ship those models to prod. So we actually have quite a lot of these kind of changes happening. So it's like almost like on a bi-weekly basis, we have a new model coming up with a bunch of changes to the taxonomy. So yeah.
Okay, thanks.
No worries.
Awesome. I think we're at time. So yeah, thank you so much for everyone for listening to us. And, yeah.